The current divider rule is a rule that allows you to calculate how much current is going through a particular section of a circuit. Using this equation, V equals IR, which is volts equals current multiplied by the resistance, you can calculate the current. The current is essentially how many volts go through a particular part of the circuit. The more volts through the circuit, the higher the current. When a resistor is placed in a circuit, the volts going through the through the circuit will go from the original ease of movement to a slower form, as not as much is allowed through. So the main use of the current divider rule is when the current splits at some point in the circuit. You'll have the total amount of current, and then it will split down the different directions. So the total current here will equal the total current of all of this. When resistors are added to this circuit, it affects the amount of current going through the available paths. A resistor with greater resistance here won't let as much current to flow through, while a resistor with a lesser value will let more current to flow. The total current through both paths will add to the total. Now for some quick calculations as an example. In parallel resistors, you have to use this equation to find the current going through a particular area or a particular part of a circuit. Now, RT is the resistance total of all the other resistors besides the ones that are in the part of the circuit that you were trying to calculate. To find the resistance total, you have to add up the reciprocals of each resistor. Now, for this particular circuit, the total current is known to be 10 amps, and for the path I1, or the current in I1, you have to multiply it by the resistance total. In this case it is just 7 because there is only one other resistor, and then you divide that by the resistor through the part of the circuit that you were trying to calculate, plus the resistance total, which is just 7. So down the bottom would be 10, on top is 70, which equals 7. And similar for this I2, you just have to switch out the RTs and R1. For a bigger circuit with 3 parallel resistors, you do need to do a bit more with the reciprocal resistors and adding them up. For this one, the total current is 20 amps, and when put into the calculations, you do have to do it does get a bit more complicated with decimals and fractions. This particular one, I'm only showing the first current because the rest of them are basically the same working out, just different numbers. And once you figure it out, it's very simple. Thank you for watching.